So that is the method. Okay, so 2 steps. Okay, so we're going to take this with an example just to show how this method is applied. So let's have an example. Let's firstly highlight this. And let me show you how this works. So example number 1. Let's underline. So example number 1, I hope you can see this. So we're going to prove the following identities. So the first one being, we're going to prove hyperbolic cos squared x minus hyperbolic sine squared x is equal to 1. So we'll call this part A. Okay, so let me show you how step 1 works. So S1 refers to step 1. So in step 1 we substitute the hyperbolic definitions, okay, into the identity. So that means we need to use the definition of hyperbolic cos and the definition of hyperbolic sine, and we substitute them into this identity. So let's do that. So just as a side note, by using, so remember the definition of hyperbolic cos from the previous video, it was e to the x plus e to the minus x over 2. And remember the definition of hyperbolic sine, that was e to the x minus e to the minus x over 2. Okay, so that's the definition of hyperbolic sine and the hyperbolic cos. Okay, so let's substitute, let's replace it. So let me consider the left hand side. So left hand side, let's consider the left hand side. So we're going to have hyperbolic cos squared. So hyperbolic cos was e to the x plus e to the minus x over 2 squared, minus hyperbolic sine, which is e to the x minus e to the minus x over 2 and squared. So I've replaced them into the left hand side. So I just consider the left hand side. Now if we expand the brackets, let's see what we have. So if we expand the brackets, we're going to have, for the first term, e to the power 2x, okay, plus 2e to the 0. So 2e to the 0 means 2, as e to the 0 is 1, plus e to the minus 2x. Okay, so this is what you should get when you expand the top term, e to the x plus e to the minus x squared, divided by, and 2 squared, as you know, is 4. Okay, minus, I like to keep the terms in brackets so it prevents me from making any errors. So if we do so the same here, so if I expand e to the x minus e to the minus x squared, we're going to have e to the power 2x minus 2, so minus 2e to the 0, which is minus 2, plus e to the minus 2x, divided by 2 squared again, 4. Okay, so this is where we get up to at the moment. So I hope this makes sense, and I can simplify further. So if I simplify further by taking a common denominator of 4, okay, we're going to have as a result e to the 2x plus 2 plus e to the minus 2x minus e to the 2x minus 2 plus e to the minus 2x. Okay, now we're going to do some cancellations, as e to the 2x minus e to the 2x, these two will cancel, and also e to the minus 2x and minus e to the minus 2x, these cancel also. So we're going to have 2 minus minus 2, which is a 4, divided by 4, and that is equal to 1. Okay, so that is equal to the right hand side. So remember, this is step number, so we substituted into both sides, okay, of the identity, and we simplified. So in the sense, we're doing step 2 also at the same time, simplifying, as I said in the method, simplifying both sides of the equation So we simplify the left hand side, we got 1. 1 equals the right hand side, which is 1 also. So to conclude, since left hand side is equal to right hand side, so therefore hyperbolic cos squared x minus hyperbolic sine squared x is indeed 1. So that concludes the proof. Okay.